Welcome to this video from Directed Energy. My name is Martin Jones and I'm with the Applications Engineering Department. In this episode, we'll be showing you how to properly operate the PCX-7401 laser diode driver. Now, here's a list of what we're going to cover today. First, I'm going to give you a brief overview of what the PCX-7401 is. Then I will list the equipment that I will be using. Next, we'll talk about some safety with this unit. And then we'll discuss the accessories that come along with this unit when you purchase one. Then I will show you a step-by-step physical test setup of the system. I will show you how to navigate the front panel touchscreen. And after the front panel demonstration, I will begin a live operation of the unit so you can actually see the unit operate. And the last will be a discussion of common faults and what they mean and how to correct them. All right, now about the PCX-7401. This is a 0 to 3 amp laser diode driver that has a current adjustment of 1 milliamp for driving laser diodes, bars, and arrays. This unit has adjustable pulse widths from 100 nanoseconds to CW or 100% duty cycle. There is an internal trigger source with a range of 5 Hz to 1 MHz. You can also use an external trigger source, and the frequency range of the unit is increased to 2 MHz. The PCX-7401 can also be computer controlled through an RS-232, USB, or an Ethernet connection. Now, some of the equipment I'm going to be using for this demonstration is, of course, the PCX-7401. Next would be a strip line, which you can see right here. The laser diode interface board. This is one of the accessories we'll discuss later, and you can see this here. The Tektronix 4102 oscilloscope. This is a 1 gigahertz bandwidth oscilloscope. I will also be using a Tektronix AFG 3051C function generator. And I have a Fluke 87.5 digital multimeter. Now, safety. Do not open the cover of the PCX-7401. There are no user serviceable parts inside. Opening the cover exposes you to shock and voids the factory warranty. Do not install, handle, or remove the output cables or laser diode while the PCX-7401 is operating. Allow at least 10 minutes after power down before handling the output cable or laser diode. Allow sufficient space around this device for air circulation. Cooling air enters the front of the chassis and exits the back of the chassis. Do not use where liquids are present or in a corrosive environment. Clean this instrument by wiping with a dry or damp cloth. Now, some of the accessories. There are 3 accessories that will come with your new PCX-7401. The first will be the strip line cable. This cable is a flexible PCB that is 2 feet or 0.61 meters in length, with a DB37 connector on each end. The part number for this is 6045-0075 if you ever would need to order another one. And as you can see right here is the strip line cable that is used for this unit with the DB37 connectors. One end is male and the other end is female. The next is the laser diode interface board with a current monitor, so you can monitor your current. This here is the board. The part number for this is 6045-0097-12. Now you can see on this board that you have the current monitor connector right here, which is J2. And you have a CVR, or current viewing resistors, on this side. The scaling for these resistors is 125 millivolts per amp into a 50 ohm input impedance. In order to measure it correctly, you will have to set your oscilloscope to a 50 ohm input impedance. Most oscilloscopes have this option built into them. If your scope does not, you would need to purchase a 50 ohm BNC terminator for your oscilloscope, like this one here I'm showing right now, to connect to the input of your oscilloscope to get your 50 ohm impedance. The next accessory is a current monitor coax cable. It will come in a sealed bag And this cable is also 2 feet long or 0.61 meters in length. It has a BNC connector on one side and a SMB connector on the other to connect to your laser interface board. You will also get a set of keys for the key switch, a BNC shorting plug for the rear enable interlock, and a power cord. The power cord you can choose from either a USA or European power cord configuration. Now we're going to go ahead with a physical setup. I'm going to turn this unit around so I can show you the rear panel. Now that you can see the rear panel of this unit, we're going to show the BNC connections. On this top row here, we have a sync output for synchronization pulses for external devices that are available for this BNC connector. The sync pulse corresponds to the leading edge of the output current pulse. The next one is the enable interlock connector. This connector accepts either an external dry contact closure or the factory supplied BNC plug. Closed contacts or use with a shorting plug enables the output. When this connector is open, the unit will not enable and put out an output pulse. The external trigger is the next one that we have on the back panel. This here is for your external trigger, and this needs to be a 5-volt trigger pulse going into it. Then we have the output DB37 connector, which you will be connecting the PCB strip line to. Then we will be viewing up here at the top, which is a USB connector for computer communications. The next one is an Ethernet connector, and the next one on the bottom of this is an RS-232 connector for all for computer control communications. I'm going to move the unit over to the side so you can take a view of the power entry module. And right below the power entry module is also the serial number. Move this back. And now we're going to start with the physical setup. I'm turning the unit around. And the first thing I'm going to connect is the BNC interlock connector to this. And since we will be using the external trigger during this demonstration, I'm going to connect my external function generator to the external trigger. I will not be demonstrating the sync output pulse during this demonstration. Now I'm going to take my strip line cable. I'm going to take the male in, and that is what it will be connected to the back of the unit. And that is now connected. Next, we'll be connecting the interface board. I already have some of this already pre-set up. I'm going to connect this interface board to my strip line cable. I have placed a short on this interface board where you would normally place the strip line if you didn't connect your laser diode directly to this board. And this short will represent the laser diode during this demonstration. I've also connected my SMB connector here to my oscilloscope so I can properly monitor this unit. And last but not least, always remember, plug the unit back in. So now I'm going to plug the unit in. And now let's turn this unit on. Now you can see the boot up. And you can see the entire front panel of this unit. Now we're going to discuss these icons that you see on the front panel here. The first one we're going to discuss is the tool icon, which is for pretty much all viewing settings. Now, if you want to view the serial number, date of calibration of this unit, this icon here, we will push or touch, and we'll see a lot of other settings here. Now, to view that serial number and calibration date, we're going to push the about. And that all comes up with model number, serial number, calibration date, or the date it was tested, and the firmware revisions. To exit out of this, we're going to hit the icon up there in that same upper left-hand corner. Now we're going to change communication settings. And if you need to change communication settings, we'll hit this tools icon again. And we're going to see a menu item, COM settings. We're going to go ahead and touch it. Now here's where you can set your RS-232, USB, or Ethernet. And you can go through each one. With the RS-232 and USB options, you can choose your baud rates. You can go through and change all these settings. And just push USB and the same menu comes up. Now for Ethernet, we're going to push Ethernet. You're going to have a choice of static or DHCP. This will be your choice. To exit out of this, after you've made all those connections, we're going to hit that button. Now, when you first boot up this unit will always be able to be controlled from the front panel as default. Now, if you're in computer controlled, you would see a screen that comes up saying that it's under RS-232 or USB or Ethernet. And if you want to return back to local control, you just will hit the local button here at the front. Next, we're going to be talking about how to recall and save settings. In order to do that, I'm going to say you've set all your settings here. Now, first I'm going to go to recall settings. And I want to recall a setting. I've already preset some settings in here. I'm going to hit recall 1. Now it's reading and updating the unit for those settings. To exit out, we exit out and we can see that the settings have changed or the preset settings that I've already had. To save these settings, it's the same process, except that you go to the Save Settings menu option, touch, and I'm going to save that and back into Save 1. You can save up to 4 different settings at a time in this unit. If you want to change one of the settings that you have saved, all you have to do is rewrite or resave under that setting. Next, we're going to discuss the trigger input. By default, it goes to internal trigger. And this menu item is right here on here. There's a little arrow next to it, which we can touch, and it gives you 3 set points. You can have internal, single shot, or external settings. For now, we're going to keep it with internal. Next is we're going to start changing frequency, duty cycle, output, and bias settings. In order to do that, we will tap on the setting that we want to change. Here we have 20,000 hertz. To change it, we can move our knob. And as you can see, that changes. If you want to change the resolution of the steps that we do, you will push this knob in and you can see it changes by a factor of 10. And you can change to 30,000 hertz. And when you're done choosing your frequency, you hit done. Next will be duty cycle. We just touch the duty cycle setting. And it's the same thing. You got your resolution here in 1 or 2. And you can change that resolution in factors of 10. Now with the duty cycle, we set by duty cycle percentage here. But if you want to see what your actual pulse width is, and period, it is right above the percentage of the duty cycle to give you a more accurate representation of what your pulse width will be. When you're complete, you will hit the done. The next one will be our output. And as with the other ones, our resolution, we can push our button. And as you can see, the step size changes. And when you have your current set, you will hit done. And your bias current is the same process. And you can take your bias amps up to 0.55 amps. And when you're complete with that, you can hit the done button. Now, if you want to monitor the internal loop currents, temperature, internal temperature of the unit, and everything else, we will hit the local button and this temperature icon at the same time. And this brings up the status monitor. The status monitor shows the firmware the temperature of the heatsink, the voltage of the internal power supply. Now we have our fault indicators in the next block, whether it be open load, key switch, cable, or the rear enable. Next would be bias readings and main current readings up front of the loop currents internal to this unit, and a system fault error code. To exit out of this, we hit the exit button up there in the upper right hand corner. Now these icons here show whether your faults or your safeties are enabled or disabled. Right now, as you can see, the key switch is red. That means I have it in the off position. The next center icon here in the bottom for faults is that rear enable BNC. And the third one right here is your output cable. If these are not engaged or part of the unit, they will turn red and it will not allow you to enable the output pulse. Now we are going to go ahead with the demonstration. I'm going to pause here. I'm going to turn on that key. All right, we are now going to go ahead and do the live operations. I've already done the first setting and have it set up. I have all my interlocks set to where it will allow this unit to put an output pulse. So in order to do this, I have my oscilloscope set up here, and I'm going to hit the enable button. I'm going to reach around here, push enable, and now we are getting a pulse, a current pulse. I'm going to adjust the time base on here so you can actually see the current output pulse of the unit. Now this here is a 3 amp pulse. Now I'm going to double check my oscilloscope here, channel 1, to make sure I have it in the 50 ohm mode, full bandwidth, and I do. Now you can see that pulse. Now I'm going to go ahead and do another setting here for recall setting 2. I'm going to come around and we're going to show a live demonstration at a close-up here. I'm going to recall setting 2. Now, as you can see, we've recalled the setting. I'm going to go ahead and exit out. Give me a moment here so I can see the front panel myself. Exit out of there. Hit the enable button. Now this setting is, we have a 0.5 amp bias and a 3 amp pulse. In other words, what we're having is a 0.5 amp above 0, and then we have an extra 3 amps above that 0.5 amp. So we have a total of 3.5 amps going out to the load. Now the bias is used as a simmer current to help increase the performance of your laser. Now that you've seen that, we're going to go to full bandwidth. I'm going to disable the unit. Going back to recall settings. Now as my third setting. This setting is set up for 3 amps at 1 megahertz. And this is so you can see the unit operating at 1 megahertz. Let's go ahead and exit out. It's been loaded. Now I'm going to hit the enable. And you should be seeing the waveform here on the oscilloscope. I'm going to go ahead and change the time base of the oscilloscope. Now this is all set for 50% duty cycle. You can adjust it from 100 nanoseconds up to CW, or 100% duty cycle. And here we have 1 megahertz. Now I'm going to disable the unit. I'm going to go ahead and demonstrate the CW, or 100% duty cycle setting. tools icon, recall setting, recall number 4. Exit out of that. Now I'm going to start, I have it set up for 5 hertz, 100% duty cycle at 100 milliamps. I'm going to go ahead and enable the unit. I'm going to adjust the scaling so you can see the CW signal or DC going to the output and how clean it is. This here is at 100 milliamps. Now I'm going to adjust this to demonstrate the fine adjustment. So I'm going to go to output current. I'm going to change my scaling to 1 milliamp. Now I'm going to start adjusting at 1 milliamp, and as by 1 mil, you can see from the scope shot that it is adjusting nicely. And we can change the scaling. Now we are at 200 milliamps. And I'm going to go ahead and take this all the way up to the 3 amps. I need to come around so I can see exactly how far up I am going. And we're adjusting here at 100 milliamp resolution. We're at 2.5 amps there. Change my setting. Now we're going to go all the way up to 3 amps. I'm going to go ahead and hit the done button. And as you can see, we have a clean 3 amp signal. I'm going to go ahead and disable this unit. And now I'm going to demonstrate the external trigger. This trigger, we can take the frequency range all the way up to 2 megahertz. To do this, I'm going to come back around front here, hit the trigger option, and I'm going to set it for external trigger. Now I have the current set to 3 amps. I'm going to go ahead and enable the unit. And we have no current out yet because I have not enabled my pulse generator. We're going to hit the enable button here. Now we got 1 megahertz output, as you can see. Now I'm going to adjust this up to 2 megahertz. I'm going to change the time base. I need to come over here to set this to frequency. And let's take it right up to 2 megahertz. Now, as you can see on my oscilloscope, we have a 2 megahertz, 50% duty cycle pulse width coming out of this unit. Now I'm going to go ahead and disable my function generator and disable the output on this unit. I'm going to set it back to internal trigger. And we're back where we started with this unit. Now we're going to discuss some of the fault conditions and warnings that you will see with this unit. Most of the faults with this unit will be an overcurrent or an open load fault. Also, you will get warnings with this. If one of your enables, your safety interlocks are not enabled properly, the unit will also let you know. And I'm going to demonstrate this here. So I'm going to come over to the side. I'm going to turn the key switch off. Now I'm going to try to enable the unit. And as you can see on your screen, it comes up with a hardware warning. It tells you that the front panel key switch was off while the output was being enabled. Now with this is just a warning. So you can go ahead and clear your warning. Turn your key switch on to clear it. And now you will be able to enable your unit. This will also happen with your rear BNC safety interlock as well. Now another one is for an open load. Say your load opens up and you want to try to enable the unit. I'm going to disconnect my load, place it here. Now this fault here, when this fault happens, you'll get the warning. I'm going to enable and get a close-up of that. And you have to wait a few moments before you can clear this fault. And it'll tell you open load fault. Now, after a few moments, you can clear the fault. You will need to correct this fault. And also, as you notice on the front panel, is that your current settings go to 0. So you will need to readjust and reset all your current settings for this unit. Now, in this case, I just need to reconnect my load, and I will need to reconnect or redo my output setting. And I'm just going to go ahead and set it to 1 amp because there's going to be another demonstration here for the current monitor. Now, with this oscilloscope, we've had questions about this before in the past, is that we use your current monitor, you say it's 125 millivolts per amp resolution. The one thing you got to remember about an oscilloscope, it is not a voltage measurement device, or a very accurate one at that. And on this one here, I'm going to go ahead and enable it 1 amp DC, and we can see that it enabled. I'm going to change my voltage scaling. I'm going to take this cursor down here to read. I have approximately 130 millivolts, 132 millivolts that it's reading. And that's with the oscilloscope. Well, that's off by a little bit. But since that is a DC, a good way to measure this is to use our digital multimeter, which is being shown here. Now I'm going to turn this to a millivolt scale. I've attached a special BNC to banana plug jack with my 50 ohm terminator. You have to still add that to it. For a DC, I'm going to attach it to there. I'm going to enable my unit. And on this here, it is very accurate. It comes out to be 124 millivolts for that 1 amp setting. So the oscilloscope, each one of the oscilloscopes, and this oscilloscope was just calibrated just 2 weeks ago. And we've had different types and different manufacturer oscilloscopes, and they all read just a little bit different from each other, and they've all been calibrated. Now I'm going to go ahead and disable the unit and reattach to my oscilloscope. Put my multimeter back off to the side. Now, if you have any questions or comments about this video on how to operate this unit, or if you have any problems with it, or would like to know more about the PCX-7401 laser diode driver, please feel free to contact us via phone or email. Thank you for joining us.